Have you ever wondered how defense systems track supersonic threats through invisible fog? The answer lies in the electromagnetic spectrum. Welcome to Radar Systems. Today, we are visualizing the invisible. We will turn radio waves into precise data. This is the PPI scope. The rotating line sends out bursts of energy. When this energy hits an object, it reflects back. These reflections appear as blips. But a blip is just a dot. To find the exact location, we need to freeze time. This is the pulse echo principle. We have a transmitter and a target. We send a signal at the speed of light, c. The pulse hits the target and reflects. The radar measures the round trip time. Here, it takes exactly 10 microseconds. Since the signal traveled there and back, we divide the time by 2. 10 microseconds means the target is exactly 1,500 meters away. But location isn't enough. We need speed. For that, we use the Doppler effect. Watch the frequency line. As the target approaches, it compresses the waves. The frequency shifts higher. This is the blue shift. Conversely, if it moves away, the frequency drops. By measuring this precise shift, FD, we calculate the target's velocity instantly. Real engineers don't just use lines, we use 3D Range-Doppler maps to see through the noise. This is the power of signal processing. Subscribe to dive deeper into phased arrays.